This video is going to help us understand how to do Lewis dot diagrams for atoms, ions, ionic compounds, and a reaction forming an ionic compound. I'm going to start with our Bohr diagrams. So our Bohr diagrams include a nucleus, which has the number of protons and number of neutrons. So in this case of the sodium atom, it's 11 protons and 12 neutrons. And then it has each energy level and how many electrons they have in it. So I have 2 electrons in this first energy level for sodium, then 8, then 1 for the sodium atom. A Lewis dot diagram is trying to cut to the chase, and it's saying, you know what, I'm going to assume that you know that sodium has these things, and I'm going to call that Na just to represent that that is sodium. And every time you see Na, that's what I mean. I mean the nucleus, and I mean those full energy levels, just so that we can focus on just that valence energy level. And so I'm going to delete all of this stuff and write down just the symbol Na to represent all of that at the same time. Then it has 1 valence electron, so I'm going to put that 1 valence electron on the top there. Now that was kind of a clunky way of thinking about it, but that's what it represents. The smoother way of thinking about it is to say, hey, I recognize this is an atom. I'm going to look on my periodic table and I'm going to notice that it's in group 1. That means the first column. And when I know it's in group 1, I know it has 1 valence electron. So symbol 1 valence electron, and I'm done. That's a much faster way of looking at it. This, instead of thinking about the nucleus, the first energy level is full, the second energy level is full, and then I'm done because I need to have 1 less electron than protons in order for it to be positively charged. Yes, you need to know all that stuff, but just to draw the Lewis dot diagram, that's a bit clunky to think about it that way. So this is the way we're going to think about it for this one. I see that this is a cation, not an atom, but rather an ion. And so I'm going to take this cation, and I know that all cations are going to be empty with their charge. So for this sodium, I'm going to go sodium symbol is empty with its charge, and I'm done. Here I have an atom again. Let's try this twice more. So here I have an atom again. Because it's an atom, I look at what group it's in. I see that this is in group 6. And so I know it has 6 valence electrons. And so I'm going to draw the symbol S, which represents all those things, and then 6 valence electrons. 1, 2, 3, 4, 5, 6. Now when you're drawing these electrons, it's very important that you first put them in these 4 spots. It doesn't matter which one you do first, second, third, fourth, but as long as these 4 individual spots are filled first, and then with the 2 extra, I can pair them up. And I could pair up those 2, that would be correct. I could pair up these 2 instead, that would be correct. It doesn't matter as long as I have 2 pairs and 2 that are not paired. That would be the Lewis dot diagram for the sulfur atom. Here, this is not an atom, but rather it ends in "ide" instead of like the periodic table is sulfur. This is not what's on the periodic table. So this makes this an ion. With ions, this is an anion because it's negative. With cations, they were empty with the charge. With anions, they are full with the charge. And so this is going to be S, and by full, I mean the octet rule of 8, 2 minus. Okay, so for atoms, we look at the periodic table, we say, hey, what group is it in? It has that many valence electrons, and we draw the Lewis dot diagram. For ions, we look at whether it's a cation, it's empty, whether it's an anion, it's full, and then we put the charge that it belongs to. Remember, all group 6 are 2 minus, all group 1 are 1 plus. Okay, so that's how you do atoms and ions separately. Here, if I'm asked to do sodium bromide, I recognize that sodium bromide is an ionic compound. The ionic compound has the formula of NaBr. And so I'm going to need to put the Lewis dot diagram for the Na plus and the Br minus. So it's just like this, but twice. So the Lewis dot diagram for sodium ion looks like this. empty with a charge, just like I did over here, right? Empty with a charge. The bromide ion is going to be full with a charge. And I'm done. That's what, if this is what sodium ion and bromide ion looks like, then sodium bromide must look like that. Sodium bromide, done. Okay, so here's a little bit harder of a twist. Sodium sulfide is Na2S, so the sodium ion looks like this, just like it did before, empty. The sulfide ion looks like this, full with a 2 minus. Okay, but here's a little thing we need to change here. In sodium sulfide, I notice that I have 2 sodiums for every 1 sulfur. I have to indicate that here on my final ionic compound. And so I need 2 sodium ions for every 1 sulfide ion. Or I could have actually drawn it twice. So I could do this, or I could do this, and just draw that sodium ion twice. And now I'm representing that I have 2 sodiums and 1 sulfide in my ratio ionic compound. Okay, so atoms, look at the periodic table. The group number is the valence electrons. Cations are empty with their charge. Anions are full with their charge. Ionic compounds, you just do ion, ion, and look for the ratio, 1 to 1. Ion, ion, and look for the ratio, 2 to 1. Okay, so now, what if I have to do all of this all together? This is what it looks like. If I was doing a reaction where I took a piece of sodium metal, so this is solid atom, and I took a sulfur atom, which can't happen, but let's just, for simplicity's sake, okay? So I took one S atom, neutral, and I forced them to come together. Well, the sodium atom, according to this work that we did here, group 1, 1 valence electron, looks like this. The sulfur atom looks like this. Group 6, 6 valence electrons, like that. And this is quite unstable, doesn't have a full octet. This is quite unstable, doesn't have a full octet. So if I were to put them together, this sodium would like to transfer its electron to that sulfur atom, like that. But the sulfur atom still isn't satisfied, right? It's a little bit better, but it doesn't have its full 8 yet. The sodium is very happy. So I actually need a second sodium, because remember I have a whole beaker of these things, right? So I need a second atom of sodium to give its electron to that spot of the sulfur, and then now the sulfur is satisfied and these 2 sodiums are satisfied. And so what ends up happening is that sodium has lost its electron and it becomes Na+. That sulfur has gained electrons. Oops, I'll stick to the same colors here. So this sulfur has gained 1, 2, 3, 4. It was like this. It's just gained those purple electrons like there and there. Now it has 2, 4, 6, 8. It's quite happy. Square brackets, 2 minus charge. It's super easy to see how it's 1, 2 minus charge, 2 extra electrons there. And I needed 2 sodiums, 1, 2, for every 1 sulfur for that to happen. And indeed, when I did sodium sulfide up here and recognized it was sodium sulfide, I had to have 2 sodiums for my 1 sulfide, just like I have here, 2 sodiums for the 1 sulfide. So when you're doing these all together on one great big worksheet, you have to pay attention as to whether you're asked to do the Lewis dot diagram for an atom, a cation, empty with a charge, a cation, empty with a charge, an anion, full with a charge, anion, full with a charge, the ionic compound, pay attention to the ratio, or the reaction, which is atom, and atom gives you ionic compound. And then I see the transfer that happens there in order to bring stability to those atoms. Okay, so that's actually quite a bit to practice, and chances are you've practiced this by itself and this by itself, then these by itself, then these by itself, And the hardest thing to do is to put it all together and to recognize what you have to do when they're all muddled up together.